So intermediate, I think, is done. Let me check. We were in advanced, right? Advanced means, let's quickly take a look at intermediate. Yeah, intermediate we covered, then in advanced we actually covered some bit of it, like subqueries. So I mentioned that in subqueries, we can also like mention it as a table like this from this particular table, which is not currently in the database, but we are creating it on the fly using our select query. So also in where condition we can do that. So this also we covered, like if you want to find the records where date is minimum, but generally we put it like some value here, but in this case we do not know the value, or that value might be changing. So what we are doing, we are first getting that value from our subquery, and that value will automatically be here, so we can get those records. And also in join we can do that, so that whenever we are joining with other table, that other table uh, might not be in the database, so we are creating it by some condition while joining. So there also we typically use subqueries. Yeah, the same is there. Here we are actually using group by also. So this is a valid like reason also, because sometimes we need to create some table by aggregation. So we are grouping on date, and then counting the total number of incidents per date, and that table we are saying sub, and then we are joining with the incident table on this condition. So that is something a logic side, but from the code perspective, we are grouping and then using subquery. Then here again, this is, I think, yeah, this is like another class which is called window functions. So here what we do is like aggregation again, but aggregation do not change the total number of record. For example, if you take example of sum aggregation, so that sum aggregation means we take a sum of different set of records, but and similarly for count, min, max. So those are like that kind of aggregation. But in window function, we do not, we again take some kind of calculation, but still we place the value per record. So for example, here this is a format that we typically use. So we mention the aggregation function and the column on which we want to apply that aggregation, but you will also see this keyword over. So in over means it's a rolling window. So we create a window and it keeps rolling. So we are saying I want to take a duration seconds over this particular start time. Like I'm saying, I want to keep calculating my duration seconds, and I want to save that as running total. Now order by is different. So what we are doing, we are saying whenever we are calculating that particular new column values by taking a sum of duration seconds, just keep first order the records in as per start time. So start time is something which you are taking order, and then after that we are taking sum of duration seconds. So if you see here, uh, that plus this equal to this, then this plus this equal to this. So we are like taking some row by row, and that row is like previous row plus the new value, which is like this. So that is like how we are moving, and that is called therefore window. So window is like a fixed length, but still we are keep moving row by row. So that is also sometimes we need to take, and other concepts actually emerge based on this window concept here. For example, you will also see two different keywords inside over. One is order by for ordering based on the particular column, and partition by. So the logic of partition is that whenever you are rolling the window, that window will not roll in the complete row, all the rows, but only in a fixed partition. So whenever we partition by some column, first SQL will create different groups for that partition for the start terminal values, and each group window will roll. So if I give you example here, so if you see that start terminal is like this value for these three rows, then it changes for next rows. So what will happen? You can see that the sum is like by default, because nothing is beyond this. So generally at the first value, you could either see null, in some databases in MySQL, you can see that it's like this value. But the interesting thing starts from the next one, which is like this. So this is like the sum of this and this, then this is the sum of this and this and this. So it's like that, but this is like another value, right? Which is not sum of this. Why? If you do not use partition by, then definitely this value will be a sum of duration seconds with the previous value plus the new value, which is in this corresponding row. So the value will be here, which is like previous value plus that corresponding value of the column. But in this case, what is happening? We are using partition by start terminal. So now what SQL is doing, this is a particular partition for us because you're partitioning by this column. So these three rows are a separate window, and this one is a separate window. So our window will stop here. It will not move forward because the end is like the partition. Therefore, it's a new window here. We start again tagging some, and you can see at last it is keep adding and rolling, and then it will again stop because this time we do not want to take the rolling sum of all the records, but also we want to take the partitions, like doing some partitions like group by. So group by also do that internally, like creating separate group based on the condition or key. Here also, when we want to like create your rolling window, but on a specific partitions, you can provide this kind of keyword. Now you can also pass like a different aggregations also. For example, in the same table, we are not only taking sum this time, but we are also taking count and average also. So that is similar to earlier one. Instead of one, we are taking more columns now as per aggregation. Now here also we are saying that the same thing, but what is happening? We are also taking the order by partition by, and you will notice that here there is no order by. So order by is important because without order by, you can see that the sum is actually not reflecting. The value is the final value. So whenever you add these three, the sum is actually there and it's not like ring. So therefore order by is important. We need to use order by also so that the results look correct. So the only difference between this and this is here we are using order by also start time. So you can see that values are looking cleaner. So whenever you use whenever somebody asks you question in interviews that, okay, let me get this table by writing some SQL query. So make sure to use order by also by some column which you think take us, like for example in this case start time. So that kind of order by is important, and along with partition by. Partition by is optional. We can use partition by if you want to, like also they are asking for some grouping like a rolling window only in a specific partition. So that is yeah, I mean there are some functions also where for example here we are trying to get row, so row number. So whenever you roll, we are not using partition here, right? So only the simple rolling is happening of the window, and we are taking this function. We are saying not any aggregation kind of thing like sum min max, but row number. Row number means is SQL will automatically calculate the row number in which they are, for example 1 2 3 4, and they keep adding. But if you also add partition by here like this, we are adding partition by now. So you will see that start terminal this 1 2 3, then again 1 2 3 4 5. So sometimes we also need that kind of info, like at which row we are in, and not only directly all the rows but also partition by rows number. In that case this function might be helpful, where you can use row number. And rank also we can apply. So rank is like again at which rank we are in. So but the only difference is here you will notice that whenever we rank, you can see like this, so that the value is maybe similar, the value where value is being derived based on the order. So whenever you order your start time, that start time value is exactly same, so therefore the rank is also same. The row number will definitely increase, keep increasing, but the rank is based on the value of your order. So start time is same in that particular column, therefore you can see that 4 4. But this is like pattern also, where generally you will, if two rows are same, the it's not like 4 4 and then 5. No, whatever common values are there, they will get equal rank, but they're considered as particular place. Like if you take 4 as like rank here 4 4, so it's not like next number will be 5, it will be 6 only. But it's just a pattern to show that these are equal. based on your value of start time in at which you are ordering. Then we have entile. Entile even I do not use much. So it's like percentile is something which you typically use where pass 100. But if you want to use also some lower number of quantile and all that. So for if you're using only 4, then that is called quartile. If you use 5, quintile. And similarly, you might be familiar with this percentile concept, like out of 100. So those also we can consider, but these are not that specific, and often you will see these kind of logic here, entire logic. Lag and lead are you will see. So lag and lead are also pretty famous, where what happens if you apply lag, so that means the previous value. And in lag, not only you mention the column name on which you want to calculate the lag value, but also the distance. Like I am saying that I need a lag of this column by one separation. So it's like a previous lag. The previous row, whatever that value is, I want that value in my current column, which I'm naming lag, simply lag. You can mention any name here. Similarly, I'm saying lead means next column or next row. So I'm saying whatever the value is there in the next row. And if I say 2 here, what will happen? Whatever the value is in the uh, second row from bottom is like next to next row is like 2, gap of 2. So that means it's like how we decide the lag and lead. And sometimes we also need that, therefore these kind of concept of window functions also come, like lag and lead. So if you can see here that duration second is our column on which we are targeting, and we are seeing in the lag column the previous value, just a difference of 1. So you can see that this value is coming here whenever we roll onto this row. And similarly on the same row, what we are seeing here, nan is because like generally because there is no lag, there is no previous column for this, therefore you can see nan. And all the values where nan is occurring, that means it's not, there is no value to fill there, something else. And then lead means the next value. So you can see that whenever we have on this row, here we have nan because there is no lag, there is no row before this, but lead we have row because next row is available. So this value is coming here. Similarly, when the window comes on the second row, the same logic will be applied. The lag is the previous one, lead is the next one. And you can see that the same logic applies and it goes to the end. But on the last row, what is happening? You can see the same pattern, but here there is some new number which is not there. So it's because simply you are printing limit 10. So definitely 11th row, index 10 is definitely this number because the lead is coming as that value. Now partition by order by, yeah, I mean, you can also like kind of subtracting here. Here we are saying duration seconds minus the lag of duration second by 1. So it's also interesting where we are saying subtract the current value uh, minus the previous value. So the you can see the taking the sum here. So it's like, but here this time you can see nan 2 times. Why? Because we are partitioning by also. We are saying partition by start terminal. So the window will not be applied to globally, but in each group on which we are partitioning. So this is one group. We are applying our window here, logic here. So nan here because there is obviously nothing to subtract. But here we have something to subtract. We are getting the value here also, this minus this. But here it's the new window. So again, start from nan and keep on subtracting. So it's like how lag and lead works. Then select star from this particular query. Yeah, this is like we are applying our typical query here, and then we are applying making it as a subquery, so that when we select all from that particular table, we are getting this kind of value. Again, entile, nothing important here. And then we have X, yeah, this I like, I mean, these are all pretty much keywords here. Entile, you can remember if you want to study, you can do that. But I mean, focus on like those are interesting ones are lag and lead, and also obviously partitions like partition and order in these windows. So those are like main concept, and I would say uh, row number is also sometimes we use. Then yeah, these are like aggregations and all, but concept is like window concept here. Window concept is important. And also like where we do not use order by, so that what happens, we have all the same values. So that day also make sure you use order by. And that ends like our window. But a last concept also in advance is sometimes they ask you like how to optimize the query. So there is a concept of explain in SQL. So whatever query we wrote, something like this, and this one is optional, it just print in a JSON format. But whatever query we write, if you use explain keyword before that, that will bring you the query planning and the cost. So when we run the query, the SQL engines are different, like MySQL has its own engine, Postgres has a different engine, and there are a lot of engines. Presto engine, Snowflake has its own engine, Databricks is Spark engine. So there are a lot of different technologies for database. So in each one, whenever you run the query, the engine actually plans it, like how to plan it step by step. So that planning also you can get, like you can get that information by using this keyword. So you can see here that when we run this select query, select star from there where all this filter is applied, limit 10. So we got some kind of planning. But the important thing to notice is that in each plan, in each step, you will also get the cost information. So whatever the cost is, read cost, eval cost. So our goal is to understand the cost that is happening at different level. So for example, 7,590, I mean unit I think is not that important, but the relative you can say, the value, for example 7,000 here and 8,000 here, then uh, rows examined are 73 and all that thing, and then again the read cost is 6,000 here, eval cost 820. So these kind of costs relatively matter, because what happens, you want to first pick up the step which is taking the largest cost, and you focus on that and think like why this step is taking this long of cost, and then you try to reduce that cost if possible, and then move to the next step until the whole query is optimized. So that also people sometimes do. So here I'm just explaining it, like if somebody asks you, I mean we generally do not do in interviews all this, but if somebody asks you like how to optimize your query, you can say explain is the way where we can get the query planning, and based on that we can estimate, analyze the cost of different steps, and then we, in decreasing order, we can start analyzing the steps and see if we can optimize that step by step manner. So that is something you need to explain in via this examples or something. Example is not important, but they want to just know if you know these kind of concept also. Then another way to optimize it is limit. So use limit. Limit actually is something which is very famous, because it not only increase our speed during development, but also do not put a lot of money or time pressure in servers, compute pressure in servers, because you can easily get all the records, like a sample of record of a particular value with limit. So that is something we definitely should use, and that is not a actual optimization, but it's still that comes under the performance optimization of the query, so that people actually do mistakes when they do not use limit during development, and therefore that is also one of the way to optimize it. Then I think the third way would be, it's not here, is no notes mentioned. If I open this one, explain, then yeah, limit actually, one more thing about limit, it doesn't gets benefited during aggregation. So what happens if you aggregate the I mean the whole data, if you have million rows, all the million rows will be used to calculate your count, and then limit will not help, right? So because you will anyway get only single value, single row, so limit will of no use there. So make sure that on the big data, when you are using aggregation, you have to take special consideration about, like it could take a lot of time and also resources. So this also, like during the limit, make sure of that also, and you can even mention this point that limit is also good way, but during aggregation it doesn't work. So we can use something like this. So we are saying that if you want to limit the data set before performing the count to speed things up, try doing it in a subquery. So this is the logic here, that if you want to aggregate on something, right, and you want to take some kind of optimization using limit. So what we are doing, we are saying select all from this table and limit 100, and then we are taking the count. So obviously count is not that important here, because count we know, limit is 100, so count will be 100. But let's imagine another aggregation function, let's say average. So not only you are getting like average of 100 records, that way if you want to use your limited rows and want to do some aggregation on limited rows, then you have to use subquery. So that also you can mention, like limit, and why limit doesn't work in aggregation and how to work there. So that all 3 points you need to mention in limits. Then table size, yeah, this is also very interesting, where you can reduce your table size. For example, let's say after explaining the particular, I mean before explaining also, generally if you are aware about your data set, so you can easily filter the table number of records. So instead of million records, if you apply this filter and you think this will give you the answer that you are working on, then simply we should definitely do some filtering, so that the number of records can be reduced. So that way, for example, here we are saying limiting to a small time window. So we have to also use this if we can. So these are like pretty much, mainly the explain was there. Explain is the main one. Then limit, and also this kind of filtering is also comes under optimization. Yeah, I mean this ends our SQL part, where we covered started from basics. You already were good at that. You mentioned that you know all the keywords. Then we start intermediate. You also are familiar with that you mentioned, and then the advanced, where we covered subqueries, we covered window functions, optimization, and I think one or two concept new were, yeah, dates and strings were there. So those are like pretty much 4 5 things which comes also in SQL. So with that, I think we covered all the concept in SQL, and so far we covered Python and SQL intermediate. I think today we covered advanced. And then after this, in our curriculum, if I say we started with Python, right? You mentioned that you want to start with Python. So I explained also a couple of code in Python. Then we anyway set up all VS Code, Anaconda stuff. Then in Python we covered the basic and advanced. Then we have SQL also basic advanced. Then the next one we can pick either, I think the first one also we have GitHub, I think we covered. Bash also, I think Bash might be pending, so let's quickly cover Bash. It will not take much time also. So let's say Bash. So basically Bash is like a as a data engineer we should know about command lines. So basically if I open terminal here, I will quickly give you some commands. So basically the first command is because it is a recording session, so you can again like come back, and if you want to make notes at that point, or you can also come back to this moment and for all the commands that we mentioned. So general commands are like, first of all, I want to get a list. So you can see that when I type ls, that means list in the current folder. So I'm seeing curriculum, Python, session, SQL, and there is another way called ls minus al. So that way you can get the same list, but in a like a structured way, where hidden files are coming here. These two are hidden files. Then this anyway comes because it is like dot and double dot means current folder and parent folder. So these two also generally comes in Unix based systems. Then we have the our main ones are like these four: curriculum, which is a markdown. Then we have sessions, which is a markdown. Then we have SQL folder and Python folder. So I can also say the same thing and give some path. For example, if I say Python, that means that is equal to this, like current folder and then inside that Python. I can do either. And when I say list, you can see that the list I'm getting is now of a given path, which I mentioned. And any path in your system, you can say, you can mention it here. It's not relative. You can also say absolute path, and any path which you have in your system, it will work. List is like, this is how the listing works. Now, another thing which we generally use is to create the folder. We call mkdir and we provide the name. For example, let's say temp. So you can see that temp folder is coming now, this one. So if you want to move inside temp, we say cd change directory. Now we are inside temp. You can see the temp, also this kind of notification here, temp. We are inside temp. And if you again say list, you will notice that nothing is coming, only these two default values are there. So if you want to create a file inside this, for folder we say mkdir, for file we say touch sample.txt. You can see that now we have sample.txt file
So
inside
this
the
is,
temp.
I'm so sorry to interrupt you, Sparsh. This is something like a Linux, I could say.
Yes, correct. It's kind of a Linux, or I would say Unix, like it's a Mac, but it's kind of a Unix commands. But on Windows, some of them will work, some of them will not.
Oh, okay, okay. Go ahead. Yeah, yeah. Thank you.
Yeah. So after this, like a file we create, and if you want to list the content of the file, we say cat and sample. And also one more thing which actually comes very handy. So you notice that I just says s, and I know that only one file is there. So I don't have to type I mean the complete command or name. I simply tab. I put tab button. You can notice that automatically the terminal detect and complete the command for me. So it's very handy. You can reduce your total command time by half just by using this kind of thing. So tab is something which we typically use to complete automatically things. And you can see that it's all blank. Now if I try to put something inside that, so let's say echo and hello world, and I would say sample. Now if I again print the content, I can see this content is there, and on sample.txt the content is there. Right now let's say echo hello world again, and if I say, you can see overwriting, right? But if you use double arrow like this, you can see the append is happening. So it's like double. So overwrite versus append, you can simply control by these arrows. So if you say insert or append mode, double arrow, or overwrite, single arrow. So it's like you can keep adding more and more content here. For example, if I say hello world 3 like this, and then if you want to delete the file, you say rm sample.txt, the file deleted is here. Like, but in VS Code, the feature is like it create a cache, but you can see crossed, so that means deleted. On the folder also nothing is there, so that is deleted. Now if you want to come back to the parent folder, so what you will say, there is a parent command, right? Cd dot dot to come to parent, and now we are in our main folder. Now if you want to delete the folder, you will say rm, but this time rm temp, but it will give some error. Why? Because it will say it's a folder, so it cannot delete. So we need to use minus r flag. So then folder is also gone. Then I think we understood how to create the files, how to create folders, how to insert the text into the folder, how to list, how to copy and move. So let's say again I create a folder mkdir temp, and I go inside temp, and then I say touch sample1.txt, and I give mkdir temp2. You can see that in my temp I created folder and a file. Now let's say I want to copy this particular file inside temp2. So I say cp sample1 and the target temp2. Now my file is copied here. Now let's say I want to Also, I want to delete it inside temp2. So I will say remove temp2 and sample. So that is gone. Now let's say instead of copy, I want to move. So it's like the same file I want to move into some other location. So that way I simply replace the CP with MV. Move my sample1.txt inside temp. You can see that now it is simply moving to temp2. Now if I say ls, it will say temp2, and if say ls temp2, it will say sample1.txt. So I hope you got some basic idea now, like about this. And another one is, I think, if you want to simply, so what we are doing here is in ego, we are saying echo this, but this arrow indicate if you want to output your message into some file or not. So if you simply print echo hello world, it will actually print here only. Hello world, it will print here like this. But the same message, we say, I want to direct it to some file, which I mentioned here. So that way it actually save into file. So this one is, I think we covered, this one is like all basic that we generally use. We use all this like to create file, folder, move it, delete it, and rename it. Yeah, rename is also typically we generally use. So let's say you want to rename temp2 to simply temp3. So what you will do, we will say in Unix actually, move command also we use for renaming. So we say move and temp2, and I will say temp3. So it's a simple rename. You can see now temp3 is showing. So move is also recommended way to like rename the folders only, and files also the same will. Let's say you want to rename sample1 to sample2.txt. So you will say move temp3 and sample1 to temp3 sample2.txt. Your file is also renamed. So this is like how we move or rename the files and then echo. And other than this, I think these are all that we generally use. So this covers our short but interesting tutorial on Bash. If I move to parent, I say remove the folder, it's gone, right? Then another concept that is pending is where is the curriculum? Okay, we have, I think these four we targeted, we covered. Then this one is pending, right? Data engineering foundations. So you have any preference that you want to pick, or shall we start with some foundations?
Yeah, we can start with foundations.
Okay. So in foundation, I would, I mean, generally explain like what data engineering is and all that stuff. So let me pull some content first from my notes. Yeah, I think I found that note. Let me pull it here. A moment. if I static image, okay, copy the path, and if I set this like this, okay, cool. Just a moment. I think it should work. Just a moment. How it works? Okay. The definition. PE minus definition. Where is that? Yeah, this one. But it's not showing here in SVG. Okay, just a moment. It's not SVGs are not able to like showing, but I will try to open it in a separate window. Just a moment. If I copied all those SVGs from here, I will say this one, this one, this one, and this one. Okay. One more minute. I'm preparing the notes. I'm trying to pull it. SVG here. We have command here. Okay, cool. So if I run this set of command to my current folder, current folder CP this, CP this, CP this, CP this. Okay. Path CD to that, and cool. I have my images. So yeah. So I will actually keep opening them if required. Or I think I can directly link here. Yeah. So let's start our this one. On preview, actually SVGs do not work in here directly, but I will try to open it if I can. Yeah. So basically, the first of all comes the definition. We missed it because we started with Python and SQL. So basically, what is data engineering? If someone asks you, like, how we can answer it. So basically, data engineering, we will define is a very standard definition that you will memorize, and whenever somebody asks you, just tell it. So basically, we are saying it's a practice of designing and building systems for collecting, storing, and transforming data at scale. So you are seeing that I highlighted in two colors. So whenever you say data engineering term, there is a like data and there is engineering. So data is like yellow word. So where is collecting the data, storing it, and transforming it. So what data engineers do? They collect the data, they store the data, and they transform the data. These are three jobs. Then on the engineering side, what data engineers do? They design the systems and they build it at scale. So that's like breakdown of the different roles that we play. So we collect the data, store the data, and transform it, and also we design the systems and build it and at scale. Designing means like architecture design, for example, data modeling or serverless system. So a lot of designs, like whatever is required. So all that comes under design. Once you have design ready, you are building it. You are actually writing the process code and designing the workflows, which are like implementing from the paper or from the chart into actual systems which are working. So that is like building process and then at scale. So that means not only that systems are capable of handling limited data, but if tomorrow data multiplies, let's say today your system is handling 10 terabytes, tomorrow it is 100 terabyte. So is your system need to be changed or the same system will work? Because ideally the system which is not required to change if data scales, that is the ideal system that we target to build. So it should be auto scalable. So that means, and also it should like handle a lot of workload which is like big data workloads. So that is comes under scale umbrella. So we this is a definition which definitely I would recommend you to like understand, learn, and all that thing. So data engineering is a practice of designing, building systems for collecting, storing, and transforming data at scale. I hope it makes sense and you can remember it. Data engineering definition. And I also like I will share notes on GitHub. So some more information like all the definition, explanation in details, also some below detail. Then let's understand another concept, how the data engineering works. So it's like the overall wrapper, but this is like a data engineer. So what is the actual process that we follow? So you can see some ETL pipeline here, but I will also tell you like what are the current modern other ways which are people trying, and those are also becoming successful. So, but generally this is a standard process. So what we do, we have a lot of sources in globally, and it could be on any kind of source. We'll see next what those
Sparsh,
sources could be.
Sparsh, I'm so sorry to interrupt you. I'll have to go, but I'll take the recording from Tahir or somebody.
Yeah, sure.
Thanks a lot.
So we have sources, and what we do from these sources, first of all, we extract. So no one else, I mean, nobody else is going to extract it for us. We, as a data engineer, are supposed to make the systems. If we need to write code, we have to do that also in Python, in any other language, to get the data from the source. And that source, I will tell you in a minute what different sources we could have. So those sources are available and we need to extract the data and store in our storage system. The storage system generally in today's world are data lakes. Data lakes because we do not have to worry about the types of the data that we're getting. It could be structured, unstructured, semi-structured. Whatever data we are getting as is format, we are storing in our data lake, and then we will decide what to do with that, how to clean it, purify it, make it ready for consumption of your business, for your business. So that data lakes is reliability for us that we typically use in now and in today's world. But earlier we do not have that kind of concept, so we tried to push the data into databases, data warehouses, and also generally non-structured data like images, videos, music, and also semi-structured also to some extent because internet was not there. So all the data was not there. So generally banks and other institutions, all they were using some kind of data data from banks and all that. So generally before 2000, then in 2000 internet came, and like that kind of era was world wide web era. And yeah, people noticed that still images are not that pretty familiar, but still you can people notice that unstructured data like semi-structured means like XML, JSON what started coming at a fast momentum. So people try to adjust it into some databases and warehouses. So still people are doing that, like they are storing into JSON columns and all that thing. But the standard way now is which most of the companies are following. They do not want to load the data directly into database. They want to keep it. If your data is very easy, like you are getting in tables or in simple JSONs, which you can manage, then definitely nobody would recommend to store in data lakes. Why keeping additional layer, which is not required? But if your data is unstructured or highly complex, structure which cannot be saved directly into warehouse, then we typically save in data lakes. Those are like two storage layer which we typically use, warehouse or data lakes. That is storage for us. Then you can see that transform.
For unstructured data, we use data lakes.
Yeah, for unstructured like images, videos, songs, all that thing, PDF files, those are all unstructured data, and we use data lakes for that definitely.
Okay.
And once you have data available, then you keep refining it, transforming it. So for that, we have compute layer. So that compute is something PySpark engine, Python engine, SQL engines. So all those are like compute layers for us. And we keep using that compute layer, and that step is called transform. Extract, transform it, make it ready. And finally, when your data is ready, from data lakes, we cannot consume it because data lake generally is for storage and they do not have the capabilities to run your SQL queries on for analytics. Therefore, the final data which we prepare, we need to load into some kind of engine, database engines called warehouse generally. And warehouse is very typical because the concept is like in your company, whatever team are using, we have a central warehouse where it gives a reliability where everybody can came and they will find the data for them, and even they can use other teams data so that they don't have to go any other way. And also data silos, that kind of concept do not occur. So data warehouses are very standard to store all kind of data, and also the more importantly, we get performance improvement because the technology that we use to store and query the data in warehousing is called OLAP, OLAP. And the database is like MySQL, Postgres. So they are mainly OLTP. So there are two kind of layers, technologies: OLTP, online transaction processing; OLAP, online analytics processing. So the difference is that whenever you want to analyze your data, you need to use OLAP kind of technology to store your data, and warehouses are like born out of it. Warehouses are totally dependent on OLAP technology. So therefore, whenever you load, make sure you are loading into OLAP, not OLTP, which are like Redshift, Snowflake. Some of them are examples of that. BigQuery, Google BigQuery. These three are very like top three industries leader currently for warehousing solutions. We load the data so that analyst team, data science team start querying, running queries on the filtered or clean data. So that is the standard process, which is also famously called ETL. And now let me also tell you about some, we call it undercurrents. So basically, these are also essential at every point of time. So we have to take care of security, where whenever we are getting the data, we have to not only encrypt the data at store so that nobody can access our stored data. For example, if you are storing some password, I see, I mean, every month I see a lot of use case, I mean, a lot of cases where this company got hacked, that company got hacked, millions of record got hacked. So, but you will notice in those cases that passwords are generally not get hacked or leaked. Why? Because we store all the confidential information into some kind of hash format or encrypt format. So that is a encryption at store. But along with that, as data engineers, we have to also make sure whenever you're transferring the data from one place to another, in transit also, we have to make the data secure by doing some encryption in the transit. So that kind of security also we need to like consider, and we should be aware about security of our data. Then scaling. So scaling means whatever solutions you are building, your storage solution, your transformation solution, loading solutions, your warehouses, everything should be as much scalable as we can, so that if tomorrow data scales or requirement scales, you do not have to change the system or migrate to some other systems. They should all be auto scalable. And the third one is cloud. Now, very hardly you will see that people are using the on-premise system, which are like buying the hardwares and then working on that, setting it up. People are moving to cloud. And the reason is like, for example, I mean, obviously there are some reasons which comes to mind. For example, one is the uh, saving in buying the hardwares. For example, if you have a requirement, only peak requirement at some time, in other times you don't have that requirement, so your resources got waste if you buy them. Instead of that, cloud actually offers us like doing the activity and allocate the resources for some time and release them. So we only have to pay for the time we use the resource. So it's not the resource cost, but kind of a usage cost. So that is a major difference in cost perspective. And then along with cost comes time also, because when you multiply and do parallel processing, you can use as many machine as you want, and that way you can reduce your time by that multiplier. So for example, if your job is doing a processing in 1 hour, on premise you are limited, you have limited capacity, but on cloud you can scale that to 10 times. If you have 10 process system, you can easily allocate 100 processors, and that way your total time will also be reduced by some multiplier. So that is like time plus cost, both we are saving, and that is the main reason that we typically use cloud. So after this is like our system. I think some SVGs, that one is not coming. So this will tell us a detailed picture also. Let me open it. Just a moment. Where I can find it. Yeah, this one is very interesting. So whatever we same process is actually showing in depth. So for example, data sources, you can notice that there are like some standard sources, web services, applications, legacy systems, and direct files also is very common, like flat file, CSV file, XML file, JSON file, and all that thing. And then we have databases from where we communicate to the sources and we pull the data from the source databases. Then IoTs, Internet of Things. So for example, even mobiles and all can be considered like this. So generally IoT devices are also nowadays very popular, and definitely in future these are like becoming going to become even popular to pull the data.
Hello,
So these are like some of the example.
Sparsh.
There could be other.
Hello, Sparsh.
Yeah, yeah,
Yeah,
yeah.
there is a breakage in your voice on long time.
For a long time. Okay, not sure. I think some network issue might be there.
Now it
Is
is
it
fine.
cleared?
No, it's clear now.
Okay. So there is like these are some of the sources. There could be other also, but our idea is like show what could be what the sources means. So sources could be databases, it could be flat files, it could be data warehouses of the systems, it could be applications, it could be web services where we need to use API kind of logic to pull the data from. Once we have the data, we you can see the data lake also, like how it looks. Generally, you will see 3 steps: raw, refined, consumption. You can name it anything, but it generally represent the data movement and this particular layer. So basically, this raw layer means the data that you are getting in as is format. There is no change in the format, anything. We have a reliability layer here where we keep the data so that if tomorrow we need to build the system again, some kind of table again, we can rely on this data. So we do not change the data in raw layer, we keep it as is, that is coming from the source. All the transformation, any kind of intermediate thing if required, we store the data in our process layer. So in process layer, we will notice that whatever data you want to save, we only are allowed to save in the process layer, any kind of internet data. And once you have that data available, then the final data, which is you are we are assuming that data can be consumed and is as per the requirement of the teams, downstream teams like analyst team, data science team, executive team. So those are someone who are trusting the data, so that they are saying the data that we have at this point can be trusted and we can use it for some decisions, like making some decisions on business side or something on that side. So it's like data lake has this 3 layer, and this data, the final data, we also load into warehouses. And then you can also see some other terms are coming like governance, privacy, lineage, observability, metadata, and these are something which we also come across. So basically, governance, we use service called IAM service in cloud, AWS. Lineage, we also learn about lineage, where we see how tools actually help us to create lineage graph. Lineage means when you have some table here, can you, if somebody asks you, can you tell me what is the raw sources of that table? Generally, it's a very hard question. And when we have lineage available, we can easily do that because we have kind of a graph where we can easily see this particular final table is coming from all sources, like what are the process data sources where we store it, and from there we can also track easily the raw sources. But the lineage concept in today's world is very important. Governance is important. This catalog is also very interesting. We will also learn about glue catalog in AWS service. Then partitioning also we will learn about. In S3 we do partitioning. Then just a moment. And then we have our observability, where we also use CloudWatch and all those services to like observe our data if we can, like what is going on inside. So all those are services which we typically are using on, and these are some new terms which we, I think 10 years back were there, but still not that popular. But nowadays it's very popular also. So this is a storage layer. Then we have compute layer. So in compute, you can see that scheduling management, caching, indexing, all those are connected to PySpark. In PySpark and all that engines, SQL engines even. So generally, this kind of compute layer is there so that we can transform our data as per the requirement. And once you have final data, these are like some of the use cases like machine learning, data science, analyst, visualization, BI tools, and also we can share the data with other companies or teams, the process data that we built. And here I forgot to mention one more point. So what is happening? This is one set of structure called ETL, but there is another kind of concept which is also becoming famous nowadays. Is called ELT, where what we are doing, if we can, I mean, only in that case, we extract the data from the source, but instead of storing and transforming it here, we directly load the data into warehouse. And that data, if we can, for example, in complex cases, we cannot do that. But generally, if we can, we try to load the data first into warehouse, and directly in the warehouse, that big data, we transform it by SQL. So that is also the concept is actually now becoming very famous, and therefore SQL is also in demand again in data engineering along with Python. So that ELT and ETL are two kind of pipelines, but you will also, I think we have a practice where I will also give you some, I will show you different pipelines, typical cases of that. So, but these are like basics where this chart will stop here and then we'll continue from there. So yeah, I mean, today we'll connect tomorrow then. Tomorrow we'll continue from here for our foundations. Thanks. Thank you guys. Thank you, Thai, Pawan. Bye.
Yeah, thank you. Bye, Spark.
Bye.
Bye, Pawan.
Bye, Tahir.